Welcome everyone. Thanks for coming here. Second to last session, so I'm going to try and keep it light, hopefully. We're going to be talking about machine learning on Kubernetes, but I just want to show you the extent of machine learning and AI, how good it is. I don't know if you can read that. That's Donald Trump in Mario Kart 8. This is from a project called DALL-E, DALL-E Mini, this one. So, you can give it some text and it'll produce you some of the art. I don't want to be biased towards America, so this is Boris Johnson in Mario Kart 8. I know it's a little bit old, but I think before we start, maybe we can do a little bit of a game. Maybe you can guess what's happening, what prompt was given to this, and this is the output. What do you think this is? You can shout out. Yeah, that's very good. Chord sketch. No, this chord sketch of Godzilla on trial. How about this one? Yeah, Connect for Cucumber. Excellent. What about this one? I like this one. Ooh, this guy is on it. I need to give you something. You deserve that. I came with a prize. Whoever was going to answer a few of those, I have a prize for you. So, well, you came to the right session. Basically, that's what I'm saying. I have a I have it somewhere in my bag. Here you go. This is Lego of Tux. So Tux from Linux. So well done to. Sorry, I didn't catch your name. Well done to Drew. So there you go. That's a happy toaster. Happy toaster in the bubble bath. You guessing that one is good. What about this one? Gandalf doing vape tricks. Right. Anyway, this is this is Gandalf doing vape tricks. So this is machine learning, right? This is the peak of machine learning, data science. You can check out. There's quite a few weird ones out there. You can go on this Twitter page. Again, I'm not going to make any jokes about Twitter today. This is Edward Bunch, but all of the stuff that you just saw came out of OpenAI. It's an organization that have been doing a lot of work in artificial intelligence and data science and machine learning. It's a combination of a few of these projects that have been coming around. So GPT-3, DALL-E, and Clip. For example, there's GPT-3. You can take some text, you can feed it to GPT-3, and it produces a SQL statement, which is pretty good. It's a general purpose, kind of general purpose, not quite, but it's general purpose. For example, you can give it some emojis and train it, and then it will guess what Star Wars is. So I don't really know if this is correct. This is apparently Star Wars. Anyway, so this is another one. You give it a text and it tells you what's happening inside the image. And the point is, the reason why I'm showing this to you, this OpenAI trained all these models on Kubernetes. They had the Kubernetes clusters, around 7,500 Kubernetes nodes in their clusters, and they needed all this compute to be able to show Donald Trump in Mario Kart 8. So that's that. So my name is Salman Iqbal. I'm an MLOps engineer, just DevOps for data science. I work for a company called Appia, and I'm also a Kubernetes instructor. You can find me on Twitter. I do also have a YouTube channel, so if you want to check out some short videos on YouTube, that's what I have. This is Appia's website. So Appia is a cloud consultancy company. We're a platform that lets you manage Kubernetes. You can check that out, appia.io. That's my channel. You can contact me on Twitter, or if I don't reply, just leave a comment on YouTube and I'll get back to you on that. So before I start, thanks to KCDC for having me. Thanks to all the organizers and volunteers. It's really awesome. Now, who here does machine learning really quickly? Anybody does here machine learning? Okay, excellent. Are you all interested in machine learning? Great. Everybody does Kubernetes, I'm guessing here. Right? Okay, cool. So I don't need to explain what containers are. You know what containers are. We take runtime, we take the configuration, dependencies, stick it all in together. We got a container. And then we deploy them in Kubernetes. There's challenges. You can't really manage one container. So how do you get that to run on, multiple containers? You get Kubernetes in, service discovery, and all that kind of stuff. Anyway, that's that. So before I go into why machine learning on Kubernetes, just very briefly, you can break machine learning down into two areas: supervised learning and unsupervised learning. Supervised learning, you have a bunch of data. In this case, you're seeing a fashion data set, and it's usually labeled. So there's a shirt or whatever it is, but you get tons of data. You don't just get a little bit of data, you get a lot of data. And what you're trying to do is come out on the other end with a model. So you want to train, basically a model is a file, depending on the framework that you use. you want to train this model to recognize certain types of patterns. So you train a model over a set of data, providing it an algorithm that it can use to reason over, like, is this a shirt, is this a car, or whatever it might be. And the algorithm that you can provide, that you can use, could be anything. In this case, we have neural networks. And usually, you do not write the algorithms from scratch. You use from one of the frameworks. You use one of the frameworks that's available, and then you deploy, you put your data in, and hopefully it will train you a model. And then once it's all trained up, you can submit your data, you can serve your model so people can submit their requests. For example, if I put a image of a shirt in, it comes back and says it's a t-shirt. That's great, right? So that's all super high level machine learning. But you don't just have one model. As an organization, you'll probably end up with a number of models. So we have recommendation engine, whatever it could be. There's quite a few of these engines. And usually what you do with them is models, they get updated all the time. Depending on the data that's coming in, whatever's happening, you update them daily, monthly, whatever it might be. And you do that for everything. And you do it quite often. Monday, Tuesday, Wednesday, Thursday, Friday. And if you work for Elon Musk, Saturday and Sunday. I knew I wasn't going to make any jokes, but it's a good point. And then if you do this all manually, it's quite hard to do. And if this was me on a weekend trying to figure out why the model's not training, this would be me. I don't smoke, but this would definitely be me. But this is not where the story ends for machine learning and data science. It just starts. Because there's quite a few things you need to get hold of before you can even train your models and serve them. Serve so people can submit requests. You need to grab the training data, split up data, and get the model and evaluate the model. This is the core of data science. But what actually happens when somebody tries to do data science, they have to do a lot more. They have to figure out how do they collect the data, how do you feature extraction, data verification, and the stuff that we really care about, like machine resource management. How do we get these bunch of machines for us so we can train our models? Because there's a lot going on. And then how do we serve it? How do we scale all of this? Because people are going to be submitting tons of jobs and also analyzing the tools. So anyway, you need to do a lot of this stuff before you can even train your models and serve them so it becomes beneficial for users. Now, we've all seen this, right? This is the Cloud Native Computing Foundation landscape. If you want to do anything in a cloud native fashion, it's very easy. You go to here and pick a project, right? It's all good. If you want to do machine learning stuff, we have something similar. This is on purpose. I made it small. I don't want you to read what's on here. But this is from ML Reef. They put together a landscape of machine learning frameworks and platforms that could help you do all of this stuff that I showed you. So this is quite massive, but we're going to focus on a couple of things. So really briefly, why should you use Kubernetes as a platform to build your machine learning, to run your machine learning models, or get your data scientists to use it? There's a few things, as we all know. If you are training a model, Kubernetes gives us self-healing. If something crashes, it can come back up. No problem. We don't have any issues. So I just thought stick a meme in just so you don't get bored. We can do a lot of scheduling as well, smart scheduling. Sometimes you have workloads that require GPU, and you don't really want to run them elsewhere. So we can do that with Kubernetes. Or we just saw Marco was showing us some labels and node selectors and whatnot. So we can do that with this. Kubernetes gives us that benefit, so we can do that. If we have something that needs to run as low priority, we can also do that. And if we're running out of pods to run our requests, we're getting a lot of requests in, we can use pod autoscaler. And again, we can use the built-in pod autoscaler, so you can have a deployment, whatever your pods are. And we have this horizontal pod autoscaler, which is going to query some metrics, and based on the metrics is going to scale up. Or you can use any of the other projects that might help you to do that. And that's quite useful because a lot of machine learning tasks do come in bursts. So sometimes you want to scale out, do the thing that you need to do, and scale back down. Well, if you can scale out the pods, and then you can scale back down again. And this is, if you can scale pods, the talk that you just had from Marco about the cluster autoscaler, you can use Carpenter or whatever you use, but this is cluster autoscaler. Once our pods keep taking space in the cluster, we can spin up more nodes, so we can run our run our apps inside. Now, but how do we figure out all of this? So I'm sure we all agree Kubernetes is the best platform for this, right? Running machine learning stuff, data science. I'm sure we agree. But in the end, we'll talk about why you might not want to do that. So what I'm going to do is focus on only one or two things because there's quite a lot. And we're going to focus on some of the famous frameworks, the ones that people use a lot, like PyTorch and TensorFlow. And how can you take these and run inside Kubernetes? Usually in Kubernetes, it all starts with data. Usually in machine learning or data science, it all starts with data. You want to grab some data, extract it, transform it, load it. This looks like a box, but most cases you'll end up looking something like this. So it's quite a complicated part of your whole pipeline. But that's not where all it ends, because once you got the data, you need to train it as well, and that also becomes a bit complicated. And you have a lot of steps that you need to look after. You need to understand what's happening. And this could lead you to a situation where you're trying to figure out where something went wrong, and you end up looking at it like this. You don't know what's going on. Especially if you fired all the people, then you're kind of stuck. Nothing is going to happen. All right, no more Twitter jokes, Elon Musk jokes. We'll move on. But then again, we analyze and then we do some predictions. Prediction is where we serve the model. So what kind of frameworks are available for us to do all of these steps in machine learning, right? So this is, and then you keep going around in circles with this. So one of the things is there is an open source project called Kubeflow. People have heard of Kubeflow? Yeah, excellent. Everybody knows. So we do not need to go into Kubeflow at all, but it's an open source project. Basically one of the most, I'm not going to say useful, the most popular projects that are out there come as part of a bundle, so you can deploy them on your cluster, and they give you some of these things. So you install it on Kubernetes, you have this Kubeflow, Jupyter Lab notebooks. These are the books that data scientists use to do their job, and you can plug into OIDC, so you can do a multi-tenancy, and then you have pipelines as well, because you got to set up those pipelines, figure out how to set up the ETL pipeline. And again, you can do this in Python. You don't have to write YAML files. I know it sounds weird writing YAML pipelines in anything other than YAML, but you can do that in Python, which is useful for data scientists and machine learning people. And then I guess the most interesting bit is the operators. So operators extend Kubernetes functionality. We're going to focus on this in a few minutes, but there's quite a few operators that do extend Kubernetes functionality in a really useful way. And we got some stuff like, usually you have neural networks, you have different parameters, you need to configure them and tune them. You can do it manually, like how many number of layers you have, what's the connection weight, but you can do it automatically using a project called Cathep. You can't really see that. I think it says metadata. This is if you need to tag all your information, what your model's versioning and that kind of stuff. And then you can do some serving. This is based on KF serving. This is based on Knative. Knative basically allows you to serve models and scale them and scale back down when not needed. And then you can run any of your favorite machine learning frameworks on top of Kubernetes. You can do all of that on Kubeflow, and it's good. It installs a lot of operators on your cluster, a lot of CRDs on your cluster. Has some challenges of managing and installing. If you don't need all the options in there, this might not be the solution for you because it installs everything. You can install specific bits of this framework on your cluster, but this is again something that you have to install and you have to look after. And this is like Kubeflow pipelines. This is probably the thing that data scientists and machine learning people use the most. You write the multi-step workflow, and it's all written in Python, and then you can productionize it. You can run it on your laptop, the same way you're running in any Kubernetes cluster. And each of these blocks that you see in the pipeline, they're all pods, so you can scale them out, scale back down, depending on your requirements. Anyway, so that's Kubeflow. And again, as I said, Kubeflow might not be the solution for you because you don't need everything that it provides. So what do you do then? What if you need to use some of these frameworks? What you can do? I mean, the easiest thing to do is, of course, you can take any framework that you like. For example, we got TensorFlow here. You can take that and you can write your code. So this is just a model code that you can serve. And of course, we all know this. If you ever want to run this in Kubernetes, we can stick this in a Docker file. The model itself, we can stick in a Docker file, or the code itself, whatever we need. Or if we have a training job, we can stick this in a Docker file and run in Kubernetes as a part of a deployment. Unfortunately, you can't really see, but this is a normal deployment, Kubernetes deployment in here. And then you can run it. This is just serving a model. Once it's serving a model, you can expose it using an ingress, and people can start calling it. And you can stick a pod autoscaler in there. If there's more requests coming in, they can scale out and scale back down when not needed. I guess the most interesting bit is the Kubernetes operators. We all know operators, we love them. Imagine I submit I'm sure I don't need to explain what operators are, but imagine I submit a deployment file and to create a couple of pods in here. I submit that to API server that stores the information in a database called etcd. Then I have this component called the controller manager that's listening to changes in etcd. Once it sees, oh, there's some deployment that needs to be created, it gets in action and starts creating some pods inside etcd, and then the pods actually get created inside the worker nodes. So along the same thing, and they go pending. This is Kubernetes. Kubernetes understands pods, of course, and it understands a lot more things: deployments, replica sets, services. There's quite a few things that it understands. But what if you wanted something new? What if you wanted Postgres, right? Let's say this is a Postgres database. So you can define a custom resource definition in your cluster. As Marco was showing earlier on, he had a custom resource definition for the cluster that need to be created. And then this is the kind, we explain what this is. And then we can deploy in our cluster an operator. So it's kind of like the controller that was running that listens to changes in etcd. So if somebody sends a kind Postgres, the operator is going to kick in and it'll say, okay, you're asking for a database, and then it's going to run its own logic. This is super high level, by the way. And the operator is going to run its own logic, listen to changes in etcd, and then eventually is going to go in and spin you up a Postgres database in the cluster. I'm not saying you should run Postgres in a cluster, but this is just an example. That's what this is. So along the same lines, we have a bunch of frameworks in machine learning. This is MXNet. People ever heard of MXNet before? Yeah, excellent. It's more for like a deep learning framework. You can define like neural nets, deep neural nets for a lot of things. You can run it in the cloud. You can run it on mobile devices. So a lot of vision stuff goes in MXNet because it's like neural nets, NLP, natural language processing. There's a lot of algorithms in here that can be used. And one of the things that MXNet supports is what's known as a distributed training. Because our training jobs could require a lot of resources to be able to run. And in order to leverage like faster training, we want to be able to split up the training job so we can run it on multiple nodes. I mean, that'll be quite beneficial. So what we have is this concept of we got a scheduler in here. So in MXNet, these are all machines, by the way. So these could be a virtual node or an actual node. And this basically, scheduler is usually responsible for bootstrapping the cluster, making sure each node knows what job it needs to run. But this is a machine, so install MXNet on these on a bunch of these machines, and then you can get these servers. And server is basically where they just store some information about what the job is being run. Again, each of these, and then workers actually. So this is the server connects to the scheduler, and then we have workers. These are the bits that actually do the training. And MXNet understands the job that is split up because the scheduler understands what job it's been split up. And then the worker, each of these workers, they're all machines. They also get the jobs and they do the training, and then they can come back with a response and say, oh, hey, your job is complete. Now you have to set up your own cluster like that. You have to set up all your machines. But you can, in Kubernetes, use these as MXNet operator. So all of these then become pods. And that's great because all you need is a cluster, and you need to install this operator on the cluster, and then you can start submitting your jobs on the cluster. So for example, this is an example of an MXNet operator. It comes with Kubeflow. You don't have to install with Kubeflow. Standalone, you can install it on the cluster. You can write your own operator, of course. but you can install it on your cluster, and then you can define the kind of job you want to run. It's probably quite small for you to read there, but you can define in here what kind of architecture, like how many schedulers do you want, how many servers you want, how many workers would you like, and what job you're trying to run. It's usually like a Python file that you're running inside the container. And then also you can stick in an autoscaler. So if you need more worker nodes, no problem. They'll spin up and you can submit this job to the cluster. And you can see like we have a scheduler, we have a server, and we have workers. We can configure this. And if you have an autoscaler, pod autoscaler or cluster autoscaler, that's great because it can scale out and scale back down when it needs to, and that's quite useful. There's quite a few frameworks that make use of this operator pattern, which is quite useful. I'm not going to touch upon everything because there's quite a lot. This is Spark. People use Spark here. Yeah, excellent. Like we got a few people in here using Spark. It's basically like real-time batch processing framework for big data. You can do like data jobs, like ETL jobs, IoT jobs, ML jobs. It's quite good. And the way it works is you have what's known as a Spark driver, and is just a Java process that runs the whole thing, your application that's running. I'll show you an example in a second. And then you have a cluster, what's known as a cluster manager. Cluster manager lets you decide what kind of underlying cluster you want to use. So you can use standalone, so you can run that on your machine, or you can do Kubernetes. And then what happens then is you have worker nodes. And in the worker nodes, there's some executors that actually run your tasks. So whatever your task might be for your Spark application. And then they can run their task, and then they can report back to the driver. Basically, the cluster manager doesn't really live in. Cluster manager is like there initially to spin it up, but that directly is talking to the driver. And then you can basically run that in whichever setup you're doing. Now here's the thing though. So if you run this, and you can run this in Kubernetes, Spark as an operator as well. And guess what? They all become pods. So if they all become pods, again, same thing. Like we can scale up, scale back down whenever we need to, and you can submit your Spark application. You can monitor them like you monitor any Kubernetes resource. This is what a Spark application looks like. It's got some information about what Docker image you'd like to run, what's the actual file you want to run, and if there's like any volumes or anything like this. Again, there's quite a few things in here that we can use, and that's not the only framework that allows you to do that. There's many more that use Kubernetes as a platform to be able to run because of the scalability, and in the cloud as well. And it is managed. Now, so we're coming to an end. I just wanted to mention a couple of things. We saw how we can use Kubernetes to some extent to do machine learning, but when should we not use Kubernetes for doing machine learning jobs? I mean, I shouldn't really say don't use Kubernetes because Kubernetes community today, but we have to look at every side. There's a lot of complexity. You're running just like any other operators. You're running operators, and if you just manage a cluster, you might be able to understand other operators, but you also need to understand if it runs is absolutely fine. If it breaks, I got to understand what Spark is to be able to fix it. Because people will come up and say, oh, we need to run this. So there's a lot of complexity that we're dealing with. And again, releasing and all that stuff. Sometimes it might be easier to maybe use cloud services. If there might be, maybe you want to use AWS SageMaker. And sometimes, maybe, I don't know. Also, if you don't need autoscaling, if you don't need any of the autoscaling, then it doesn't make sense. If you're already using Kubernetes for the rest of your organization, you might want to still extend it out to data scientists. Sometimes, if not done correctly, Kubernetes can cost a lot. I don't know if you all agree, but that does happen. But anyway, before I end, I just want to show one thing. So if you run machine learning on laptops, it's kind of gets you sometimes because there's a lot to learn. If you try and do machine learning on Kubernetes, the outcome is the same, but you might maybe look a little bit cool while doing it. So, that's the same output. But again, there's quite a few things. There's a lot of complexity to deal with. So we just saw a couple of things. Just wanted to summarize really quickly. I know we only got a minute. So of course we can use machine learning, Kubernetes to build machine learning platforms, and it's got some benefits and drawbacks. As long as you know how to manage Kubernetes, that's fine. A lot of data science machine learning organizations don't have that. capability, I'm talking about like medium to small scale, I'm not talking about like large scale. I'm not gonna make a Twitter joke, but anyway, let's carry on. So check out the Appia's website. Also, we got just want to check out like learncates.io website that we got like a bunch of blogs on here, You can, if you have any questions, I know we're coming to an end, so you can catch me here. I'm going to be sticking around today and tomorrow. You can follow me on Twitter, Salman Iqbal. So what I want to say is thank you all very much for listening.